And this is chapter 7, and this chapter is all about energy. And this chapter details the primary energy sources and describes representative policy approaches to energy's environmental and economic issues and or quandaries. Now, there are costs and benefits to energy. On the benefit side, petroleum and coal generate more than 1 trillion in sales annually. My goodness, that's a lot of money. And Oil and gas provide 60% of marketed energy that humans use to obtain their current standard of living. Um, other alternatives to fossil fuel-based heating systems and electric lights, such as wood stoves and candles, they're not environmentally friendly either. On the cost side, there's a tremendous amount of negative externalities when it comes to burning fossil fuels. Um, there's health and environmental costs appearing at every stage of production and consumption. There's noise and roads in the exploration. They can strip off the topsoil, buildup of silt. Transportation involves emissions. Refinement involves emissions, and basically everything about burning energy, especially in terms of fossil fuels, involves some emissions burning and some negative externalities. So there's absolutely some positive and negative externalities to energy. Now, some notable quotes from the first page. Very interesting quotes that Anderson has here. Um, so, car production has gotten more efficient, as stated in this first quote here. It takes 26 new cars today to produce the tailpipe emission of one new car built in the 1960s. Now, solar can be competitive now if mass produced, but British Petroleum and Shell won't mass produce them because they cannot sell them. So there's a definite catch-22 here. We at Windward Community College are definitely heading into the solar panel age, and by this time next year, or even in the fall, we're probably going to have solar panels on all 3 of our parking lots. Now, this last quote is about coal. Coal is cheap, plentiful, and dirty. As cheap as dirt, as plentiful as dirt, and as dirty as dirt. Coal is little more than dirt that burns. But coal, as you can see from this next slide here. Oops, nope. There we go. Coal is dirty, but coal is definitely cheap. But there are many, many costs involved with the burning of coal. But coal by far is the cheapest source of energy out there. We in the United States use it. There'll be a slide showing that in just a little bit. And around the world, coal is the major energy source, primarily because of the relative ease of finding it, especially the ease of burning it. Okay, now energy sources that will be talked about in this chapter. Number 1 is fossil fuels, and that is coal and oil primarily, but also natural gas. Nuclear energy, the conversion of atoms to release energy, or the fusion of atoms to release energy. And of course, alternative fuels, and that would be things like electric fuel, ethanol, solar, hydrogen, and the like. So there are lots out there, but from a cost perspective, unfortunately, fossil fuels is by far the cheapest. Now, first, some terminology on the types of energy. Forms of energy. Energy itself is the amount of work a physical system is capable of performing. Okay? Energy cannot be created, consumed, or destroyed. The catch is that entropy, the amount of energy not available to perform useful work, increases every time somebody mows the lawn or lifts a finger, because energy is dissipated into the universe as heat. So we can produce energy, but we also produce entropy at the same time. Now there is kinetic energy, and that is the energy of motion. And the kinetic energy of moving air molecules can be converted into rotational energy by the rotor of a wind turbine, and then converted into electrical energy by a wind turbine generator. So to get to our useful, to get to that ultimate electricity, energy has to go through several different steps. Since the real use of a wind turbine is to convert one type of energy into another, sometimes purists call these wind energy converters, or WECs, with each conversion, part of the energy from the source is converted into heat energy. Now, the thermal energy of an energy source indicates the percentage of the energy that can be used directly in the next link in the energy conversion system, rather than being converted into heat. A coal-fired power plant is about 33% efficient, meaning that it uses 3,000 megawatts of energy stored in coal to generate 1,000 megawatts of electricity. So coal is not the most efficient means of energy conversion out there. Okay, so measures of energy. How is energy measured? Well, it's measured in joules, which is a J, or kilowatt hours. Calories. 1 calorie equals 4.18 joules, the energy needed to raise the temperature of 1 gram of water by 1 degree of Celsius. BTU is a British thermal unit, and that equals 1,055 joules, the energy needed to raise 1 pound of water, exactly 1 degree Fahrenheit. 1 horsepower equals 746 watts, and 1 kilowatt is 1,000 watts. And finally, a megawatt is 1 million watts. Now, energy loss versus energy production. Energy production or generation is the conversion of energy into a more useful form. Energy loss, however, means that energy is dissipated as heat, or for some other reason becomes unavailable for useful work. So going back to coal, if coal is 33% efficient, that means it's the useful production is just 33%, but it takes another 2/3 in order to generate that production. So there's a loss of 2/3 for every 1/3 of energy produced for coal, that is. Okay, so our next line is the world consumption of energy in 2014 and 2020. And I'm saying 2014 and 2020 because in their 4th edition had 2014, and the numbers were updated slightly for the 5th, 2020. Now this this graph shows a breakdown of world energy consumption. Let's show that here. The pie slices have not changed much to the 5th edition. So what I had available was the 4th edition, and here are the numbers. But the updated numbers, so for renewables, there's more emphasis on renewables. That's up to 13%. Oil has gone down just slightly from 32.8% to 32%. Natural gas has increased quite a bit, 3% to 25%. Coal has gone down a little bit to 26%, still pretty close to almost a third. And then nuclear is down a bit to 5%. In the nuclear case, that may even be a little bit more than 5% because we have decommissioned nuclear plants because of Chernobyl, what happened in Fukushima, especially. I think that was back perhaps in 2012 when Fukushima happened, and it really sent a chill down the spine of folks using nuclear power. But more nuclear power in a little bit. Okay, so now I'm going to chat a little bit about fossil fuels. Here we go, fossil fuels. The first one is coal. And what exactly is coal? Again, reading from the book, and I'll be doing that a lot in this particular chapter. Coal is the compressed remains of tropical and subtropical plant, primarily from the Carboniferous, that's where the word carbon comes from, and Permian periods, 225 million to 345 million years ago. So basically, the remains of dead dead plants from that period of time. Okay, now where is the coal? So North America actually has the largest concentrations of coal, followed by the former USSR, China, India, and the European Union. And the coal in our country, there would be Eastern Pennsylvania, West Virginia, Appalachian region has a tremendous amount of coal. So too would I would think Montana, Wyoming, that northern part of the United States, bordering upon Canada. The first coal mine was opened in Richmond, Virginia in the year 1745. And the United States now has almost 2,000 mines producing over 1 billion tons of coal each year. So that is a lot of coal. Now, coal is burned to produce heat and electricity and is a component of many appliances, including electric stoves, refrigerators, and water heaters. Now, the environmental hazards from coal arise from mining and combustion. Mines scar the earth and threaten collapse. Upon combustion, coal releases sulfur and nitrous oxide, the sources of acid deposition and or acid rain. So there's a tremendous amount of air pollution, I guess, primarily from the sulfur and nitrous oxides. Now there is talk of clean coal technology, or CCTs, land reclamation programs are reducing the environmental impact of coal. But this is very expensive, and critics argue that those greater benefits would come from expenditures on emission-free renewable energy resources. So it's an opportunity cost question as well as just a straight cost question. Do we spend the money on clean coal technology, or do we use that money, that scarce resource, on other sources of energy that are emission-free and renewable energy? That is a big question. Now, another type of fossil fuel is natural gas. And let's turn our page. All right, natural gas has its origins in the swamps of past geologic periods. It is primarily methane with a mix of other hydrocarbons. It's obtained from gas wells and as a byproduct of crude oil extraction. And the benefits of natural gas is much more clean fuel, clean burning, and is relatively abundant. Natural gas has a broad infrastructure available to transport it, making it relatively accessible and affordable. So the infrastructure is there to transport the natural gas, as opposed to another alternative fuel source such as solar, definitely, and hydrogen. Now, the natural gas, where is it? And the world's major producers are Russia, the United States, Canada, Qatar, and Iran. So one would think that the places that produce oil also produce a fair amount of natural gas as well. We in the United States are a major producer of natural gas, just as we are a major producer of oil and indeed coal. There is a form of drilling. Oil and natural gas is sometimes trapped within shale rock. Hydraulic fracturing or fracking releases the fuel by forcing various components of sand, water, and chemicals into the rock. And the new technology enables this drilling to happen horizontally as well. But fracking requires large amounts of water. It can release methane, and the chemicals injected into the water may contaminate on groundwater supply. So there's benefits there, but there's certainly environmental costs with fracking. And many communities are actively opposed fracking for precisely those reasons. Alrighty, this ends the first section of this chapter.